And this seminar is dedicated to helpful hints in research design and research methodology. If we start discussing research methodology in general, it will take us several days just to agree about common features or specific features in different areas of sciences. So here I will try to tell you the story about the research methodology course we're designing within the framework of the Modest Consortium, and also some helpful hints our team of developers proposes, and also my personal experience, some of my personal stories, which may help PhD students boost their research or communicating their scientific results. So the webinar overview, and we'll first introduce the Modest Consortium to those who is not clearly aware about its structure and tasks, and then I will proceed to the research design and methodology, starting with the very beginning, research hypothesis, and also continuing with opportunities to fund research by developing a good proposal with a logical framework matrix, performing research, starting with a review of literature, and also applying research methods. And here, again, I will not focus on general hints on literature review and research methods. It's a very broad topic. I would also like to share with you some specific experience about how to customize the literature database, and also discuss some of numerical methods in computing, because to my opinion, they are the game changers in modern scientific research and research activities and processing and visualization of results. And finally, a few hints about publishing results and how to make a successful publication. Start with making a successful publication or research proposal. So the proposed time scale, I will not bother you, take your attention for more than 35 or 40 minutes. Then we'll leave for 5 or 10 minutes for discussion. If you possibly have questions, you're also welcome to share with us your opinion about research design and methodology, and then we'll make summary and conclusion. So totally, it will last for about an hour, no more. And the first slide, a few words about Modest Consortium. So the abbreviation is Modernization of Doctoral Education in Science and Improvement of Teaching Methodologies. And our university is very happy to be a part of the Modest Consortium, where the University of Latvia is the administrating university of this consortium. So thanks again to Inga. She is a very busy person to get hold of, and she's at different event now, but hopefully she will be able to take a look at this seminar maybe for a couple of minutes. Then a few words about countries. It's a consortium of European countries and also Russia, Armenia, and Belarus. And I was very happy to see among the registered persons the representatives of the universities from all these countries. And the main focus of this consortium is to modernize doctoral education, and our main audience are PhD students. Here are the participants. So starting with Europe, and the University of Latvia, as I have already said, is the administrator of our consortium, and we're also very happy to have Brunel University from London, University of Helsinki, and Jagiellonian University from Poland, from Krakow, and Russian universities are represented by universities from Moscow, Ekaterinburg, and also our university from Kazan, and Belarus, Yanka Kupala State University, Polotsk State University, Belarus National Technical University, and Yerevan State University, National Polytechnic University of Armenia, and Armenian State Pedagogical University. So the list from the website of the Modest Consortium. According to the plan of this consortium activities, we are developing courses which will be further offered to PhD students. And we have developing the research methodology course for several months already. And here is the team, the multi-country, multi-university team, as you can see, represented by colleagues from Armenia, from Poland, from Russia, and by this time, we are focusing on the following aims. So the main idea is that we introduce the basic research methodology and research design framework to PhD students, so they can develop specific skills for performing efficient research in a given discipline. And so it's a broad course with opportunities to enhance your research in social sciences and humanities and physical and natural sciences. So in a broad area of potential applications, I mean, research activities. This exact seminar aims at, so again, the research methodology is a very broad area, and a lot of books have been already published discussing its various aspects of it. And here I would like to tell you a story about the practices, how we can optimize our pathway in performing, planning, and publishing the research. There is some everything is fine. I see the chat messages, and I just like to make sure that everything is fine, that the sound has not suddenly disappeared, etc. And also, I would like to discuss with you what can be beneficial for research routine and communicating science. And I will share with you some good practices. I consider them to be good practices for research routine and like literature survey or visualization of results. Let's start with setting a research hypothesis. So the very beginning of research, starting with generating research ideas, discussing meetings with your research supervisor. Now I address to PhD students, and developing a hypothesis may be considered to be one of the most difficult parts of any research, such as research within the framework of a PhD program. And let's define the research hypothesis. Well, our seminar is in English because it's intended to be delivered to PhD students from European countries, from Russian CIS countries, and our audience is multinational, so we selected English as the language of presentation. That's why I also selected some literature sources for definition from native speakers countries, from the United States, for example. So a hypothesis is an explanation that accounts for facts that can be tested by further investigation. So it's like a theory, a definition. Okay, and also an assumption, so something taken to be true for the purpose of argument or investigation. It's from the American Heritage Dictionary and also from MIT, Massachusetts Institute of Technology, course for PhD students in terms of, so the recommendation to develop their hypothesis and plan the research. Please mute the microphone because I can hear some background noise. Please, in case you do not intend to ask a question. Let's continue with setting a hypothesis, research hypothesis. So properties of the research hypothesis. So first we are asking research questions, which will in turn initiate a research hypothesis. And then we are keen to get some expected answers from this hypothesis. And research hypothesis, it's not just a simple prediction. You need to verify it by your research. And also, construction of even an initial hypothesis may require substantial research. And I guess that maybe second year PhD students have already felt it. That it's from my PhD experience too, that you started your research and your initial hypothesis proved to be not so good, and you raised additional questions, And before you develop the final hypothesis for a PhD study, well, it may take you several months or up to a year. It's again from my experience. So substantial research may assume developing an initial hypothesis. I like the term blind alley for research. So research and blind alleys come together. And if you do not see any progress towards your initial hypothesis, it's not the end of the world. So again, from my personal experience, it took me half a year to perform experiments with, well, finding the proper sizes of nanoparticles. And sometimes I was desperate because I couldn't even test my hypothesis. But finally, it was all good, but it took... please mute the microphone if you do not ask a question. Well, if, or I like to say, when you encounter something unexpected, your research situation may change dramatically. Please mute the microphone. Raise new questions and find new pathways during your research. So research is not a straight pathway, it's more like a tree that can always initiate new pathways and new ideas. Well, a story from my personal research experience. Well, I do research in microfluidics. It's a technique that operates microflows. Like in electronics, we operate micro wires of metal. And in microfluidics, we operate microchannels with liquids. And the idea of my initial idea was to apply soft matter to microfluidics and get an automated mixing platform to fine-tune polymer nanoparticles. Okay, great. I applied for an academic exchange grant, and it took me half a year to prepare to get a grant funding visa. I applied to Carnegie Mellon University in the United States. And the very first result of the experiment was unexpected because everything failed. The solutions that behaved perfectly in bulk behaved terribly in microfluidic channels. They precipitated, they blocked everything. So I was desperate during, well, the first week of my grants at Carnegie Mellon University. So thanks God, my research advisor at that university was a bit more experienced. So she told me, let's develop a model for this process. And the new research pathway was, well, what happens at microscale is different. It was our hypothesis. And let's model soft matter behavior in microchannels. Maybe we'll find different ways to control like the properties of nanoparticles. And then it took another half a year and we developed a good model. We succeeded. We developed and modeled the behavior of nanoparticles. There is some beautiful curves and plots we got and published. So it was a fruitful approach, although it took an additional half a year for my research. Let's continue. So good research hypothesis criteria, according to our colleagues from MIT and Harvard. Well, let's formulate your hypothesis. It should be clear and precise and definitely based on a theoretical ground, but it should also consider shortcomings and limitations. For example, in my model, we didn't consider all the properties of a very complex soft matter systems. The limitations were that we didn't consider, for example, precipitation or aggregation of nanoparticles, although it's a very important phenomenon. Evaluate your hypothesis. It should be logical and internally consistent. And also minimum unstated assumptions. It's a weak point of your hypothesis, and your possible critics may consider this fact, and well, you will produce a negative image of your hypothesis and PhD research. Personal attitude and hypothesis. It's a very important part of any research because we're all people, and again, from my experience, if you are convinced about your research hypothesis too much, well, it doesn't mean that it's true or not. If you believe in your hypothesis and you spend a lot of time to prove it, you forget about the general plan of your research. Assess your research hypothesis. Do not stick to proving it. And if it changes, again, do not be dismayed. Do not feel distressed. Let's continue with the research hypothesis. We are proceeding to a very important field of research, well, research funding. And to win a grant, to fund, to obtain, apply for funding, we fill in the application. And if you take a look at, well, the majority of applications, I'd like to say, for example, at the application for the Erasmus Plus capacity building grant, that grant that gave birth to the MODUS consortium, you will find the logical framework matrix there. And also almost any application form I filled in, well, it contained parts of this logical framework matrix in this or that point. And it's a table that includes, let's take a look at the left. It includes goal, purposes, results, and activities. And also indicators that will help you to identify if you reached your goal, you achieved your purposes. You need to verify your results and develop sources and means for verification. And also finally, you need to make important assumptions and also consider risks that may affect your research. Well, it's a theory, and in my university a couple of weeks ago, we played a very interesting business game during a seminar focused on grant applications. We filled in the framework matrix, and we also demonstrated an example of a logical framework matrix. It's an interesting, funny example. Well, let's develop a framework matrix for Noah's Ark from the an example from a Holy Bible. It's funny that we can develop this matrix even for this legendary situation. So the goal will be to ensure the long-term survival of human and animal life on Earth. And the specific purpose will be to survive the flood. And we need the results. So the results are the built ark loaded with supplies, animals, and people. And we have the specific list of activities like to build the ark, to collect supplies, identify and load animals. And we have verifiable indicators in this matrix. And you can see a good indicator contains numbers like 100 years, the percentage of animals or the amount of animals which prosper. The ark is built by week 20. Well, remember that the flood was supposed to happen 24 weeks after the Noah knew about it. And also ark is loaded with X pounds of supplies, and each healthy pair of species was loaded. And also responsible persons, though the Noah was responsible for that project. And you can see the means of verification are also different, like review of passengers, count of animals a century after the flood is over, and also important assumptions, because, well, no other catastrophes may happen, like no asteroids or other unexpected catastrophes, or rainfalls will not stop, or weather will not be good. So all these risks are considered. Well, this framework matrix is good for grant application. However, let's apply it to identifying research ideas. Again, it's a good approach. For example, let's consider the research results. We may, well, let's consider the generation of research ideas and what kind of results should we obtain according to the logical framework matrix. We should obtain summarized knowledge about your topic idea, narrow the topic, specific research questions are developed, and finally a working hypothesis is identified. And here to the right, the activities we can perform to get these results: to perform literature search, meetings with the research advisor, meetings with research groups, brainstorming. So again, this approach is fruitful for not only grant applications, but actually for planning our PhD study program, for PhD study. Let's proceed to now performing the research, and we identified the hypothesis. and continue with research methods. And the definition again from the Harvard University about research methods and from American scientific dictionaries, that the research methods are techniques we will use first to determine how your research question or problem has been studied in the past. And also we need to answer our research questions. And the activities performed are literature search, meetings, seminars. However, for answering the research questions, we need to apply specific methods. And they will be different for natural sciences, for physics, mathematics, for social sciences, humanities. Here, I would like to focus on numerical methods. Are they really the game changers today? And literature search. I would like to say a few words about customizing your research database and references with Scopus and also reference databases like Mendeley and the combination of Web of Science and EndNote. So I think that I'm sure that all of you know about Scopus and Web of Science, and Mendeley and EndNote is a specific software for managing literature sources and references. And here is Scopus. Scopus and Mendeley. So these two projects, they usually come together, and you can see specific opportunities to create a Mendeley reference database at the Scopus website. The same is for Web of Science research database, and their reference software is EndNote. And now let's click on the Scopus link. It took me several seconds, yes, to open it when I was preparing to the seminar. This is the website. I will switch to English. So I think that all of you know the Scopus website. And here we can start exploring the literature sources and journals. For example, if you click on sources and see the most high-ranked journals, like for example the Lancet journal, which is the journal where like the vaccine development studies are being published, and its impact factor is actually huge. It's more than 90 according to Scopus databases. It's a huge number. It means that each paper published in this journal was cited 90 times in the average. And as for searching in this database, let's, for example, search for the authors. And well, I tried to like entering different names, but for example, let's try to search Albert Einstein, and that's great. So we have found this Albert Einstein, the most famous scientist in physics, and his publications, 102 documents, and the Hersh index is 41, which again is a tremendous number. And if we click on the scientist link, we can see that we can also sort his publications by citations. Let's sort by highest, and you can see that this famous publication about quantum mechanics, Einstein-Podolsky-Rosen paradox, was cited more than 10,000 times. And this is a general example how we can find the publications of a specific researcher and a specific source. And also we can find papers with specific keywords, and let's find the document. So I'm performing research in microfluidics, and let's find, for example, soft matcher plus microfluidics. I worry a bit, so I'm typing not so fast. So let's find the papers. So again, I am sure that most of you know about Scopus database search opportunities. However, we'll then proceed to exporting links to the EndNote database, which is more convenient for performing literature survey. So here are the papers. Let's limit our search to the review papers. and then find the papers which are cited the most. Here are the cited by highest, and for example, in the Nature Materials Journal, we have this paper, and in annual review of physical chemistry, we have a different paper, and we can save these search results in a specific list. So let's do it. Let's save them to lists. And I have already created the modest seminar list here. So let's save the links in the list, and they have been successfully saved. And then we will also open the lists and see the links here in the modest Scopus database. Well, let's try to save several papers as links here. So let's do it. To save them in a special format which can be opened by Mendeley or EndNote, let's export them to our SRS file and then click on it. And now I'm opening the EndNote software, where I have also created the modest seminar library, and I can see now these links, they have been imported. They have been imported, and we can see that these links, they have been formatted according to the requirements of journals, like journals from Royal Society of Chemistry, or from, for example, as links from journals of American Chemical Society. And now I will switch to, let me do it, I will switch to the Microsoft Word, and here is the text which I can use to for literature survey, for importing references. And I can now import references from the modest or from the EndNote software. How I can do it. So when I installed EndNote, this is the trial version, and I'll tell a few words about how to download it for free. Make sure that we have selected this citation in the EndNote. And now let's insert the selected citations. You can see that now the citations have been imported, and they have the look which exactly satisfies the requirements of the specific journal. Let's switch to Lab on Chip, for example. They have changed. Or let's switch to like Russian Journal of Organic Chemistry. You can see that the references, they're formatted exactly in the way you need to format them, and you don't have to waste time to format the references. It's a great opportunity to accelerate your paperwork and writing a research paper. As for the libraries, here in the EndNote library, we can open various libraries, and I developed a lot of libraries here, as you can see, and import a lot of different papers which are saved in these libraries. The Mendeley research management, reference management database performs exactly in the same way. And as for Mendeley, it's free. As for EndNote, you can also use it for free online if you register at the Web of Science database. Let's proceed to performing research and answering research questions. As for experiments, observations, and working with primary sources, there may be different ways to answer research questions in physical sciences or social sciences and humanities. Focusing on experiment, it's a test under controlled conditions, which is planned and performed to demonstrate possibly unknown truths, or like verify a hypothesis, or determine the efficacy of something that you have not tried before. And from my experience again, so the experiment with microfluidics was failed during my internship at Carnegie Mellon University, and we decided to try a different design, a totally new design of a microchip, which turned out to be successful. Performing your research, In the modest research methodology course, we focused on the following experimental techniques. We have broadly grouped them into, for physical sciences, we have broadly grouped them into spectroscopy methods, microscopy methods, and also numerical methods, mathematical simulations. They are very specific for each PhD project, and again, it's a too broad area to discuss it during the seminar. However, I'd like to focus on numerical methods. Are they really the game changers, and spend another 3 or 5 minutes of our seminar to demonstrate some good examples of what we can do with numerical methods. So an error function is an example I want to discuss with you. It's a function which is used in statistics, in physics, in IT, because it describes like physical processes like diffusion. It's important to my research, or normal distribution, measurement results, or even error rates in digital communication system. This is a plot of an error function. And now let's process and study this error function in context of diffusion processes and microchannels, what I study. And let's open first the results in Excel. Okay, here's an Excel document I have created. So it took me maybe like 3 or 4 days to create the same curve. You can see at the slide I demonstrated you before, and it required, you can see, several hundreds of lines of the text. It's not the only part of this document, and also to modify the research conditions also required developing the very different calculation framework from scratch, and it took me another week. However, I solved the problem in Excel, and it's good, well, to make such calculations. However, let's proceed to a different software. And now I want to tell you a few words about the Matlab, which is a matrix laboratory software. It's not the only software we can use. We can also use various programs, or also develop our own scripts in Python, for example. So my students, they also tell me that Python, for example, provides more research processing or visualization opportunities than Matlab. But, well, as I'm doing research in Matlab, let me demonstrate you a couple of examples in this program. Let's open the window. It's a kind of a black box to those who is not working with Matlab. However, I will just show you the script. It's maybe, well, it's 90 lines of a simple code, half of which are commands. And I click the run, and within a fraction of a second, I got the similar curves you saw in the Excel document, but it took me a second to generate the response for 20 different experimental conditions. So it's a game changer, to my opinion, that such numerical simulation software is a much faster way to process your research results. It's not the only example. Let's change the conditions and again generate the response. It took me a week to change conditions in Excel. It took me a fraction of a second to get an answer in Matlab with our computer code. I guess in Python it will be similar. And then also let's visualize the results, like load the script from the results I have already calculated. And then, well, the calculation now will take several seconds. Again, I tested it before the seminar started. It's not an hour, it's not a minute. Matlab may require calculations for a couple of days to get a response, but thanks God here, we will get it in several seconds. Yes, here we are. And it's a beautiful picture which shows us the three-dimensional plot of that problem we solved first in Excel, then in Matlab. But it's now much better visualized. it's much better visualized. However, let's also demonstrate how we can change the conditions. For example, it was the result for an initial reactant. Let's initiate a reaction and then also perform the calculation. And we will get the very same simple results for a very different conditions of this experiment. Here's the plot. The very different, well, it's almost impossible to do in Excel, but again, it's the very same error function. However, the results will take maybe a couple of weeks to do it in Excel. And finally, with Matlab, let's also demonstrate how we can visualize the results of a different, someone is writing something on the screen. Let's also take a look that we can solve the equation and get the three-dimensional results. And finally get the two-dimensional results within a fraction of a second. It's the very same database of simulation numbers, or maybe the experimental numbers, but it takes several seconds to process them and to visualize results very conveniently. Like in Matlab, once you have a matrix of numbers, a matrix of research results, you can visualize them in many different ways, or even process images. Let's process the image I have shown you during the first part of the presentation. It's the image I took at Carnegie Mellon University, but here now it's the process version with intensities plotted at the z-axis, and we can analyze this image very efficiently and even calculate the distances between certain parts of an image. Okay, let's return to the presentation and finalize our PowerPoint presentation with some hints about publishing the results. And I was inspired by two books. So the first one is Communicating Science by Raymond Boxman and Edith Boxman, from professors from Tel Aviv University, who gave a seminar on research, publication of research papers in our university several years ago. And another favorite paper of mine is Writing Science. Well, somebody is doing something with a screen. Please stop it. So Writing Science, how to write papers that get cited and proposals that get funded. And publishing your results, helpful hints to begin with. And so it's from Communicating Science. It's a general structure of a research paper that I'm sure that all of you already know. We start with the abstract, where we introduce, it's continuing. We introduce the background and literature, perform the literature review, and then identify a gap, and finally make a statement of purpose. Well, it looks like a self-evident sequence. However, for many PhD students, at least from my experience at my university, it's not a self-evident sequence, and you need to be aware that you apply the sequence to composing an introduction to a paper. So the first question we are asking, what are we talking about? Then the methodology, the experimental part, what did we do with experiments and the results, what did we get? It's the body, the main part of the paper. Then results and discussion may come together, but for example, the author of the first book, Professor Boxman, recommends to separate them. Well, it's all individual. And you can see in many papers that they come together or they're separated. And the conclusions, what is the answer to your research hypothesis, to your research questions? As for helpful hints from Writing Science, which actually changed my mind, well, the discussion of principle versus rules, because in the internet, in many professional books, in many websites, blogs. You can you can read a lot of rules how to compose a paper, and the author recommends to like stick to several basic principles of writing a successful publication or a grant proposal. And the very first of them I liked the most was a scientist should also be a professional writer, not just a person who like writes a sequence of research results. To do it, exercise and practice. Well, when I opened my PhD dissertation 5 years after I composed it, well, I was not shocked, but I wanted to change something that I did not like in that text. So practicing and exercising, well, provide improvement of your writing skills. Also, for PhD students, encourage your research advisor to check your short, maybe a testing article, short paper, and then analyze writing in published papers in good journals, high impact factor top journals. And you should actually see how did authors tell their stories. And as for telling the story, we're coming to an end now. Well, to write clearly, you're supposed to think clearly first. It's again, looks like a self-evident fact. However, good clear writing emerges from a process of struggle, and in turn it favors clear thinking. From my experience, when I start writing a paper, well, it's so clear to me what conclusions I should have and what results and discussion section, wow, its structure. I always change it during composing the results and discussion section and change the conclusions. It's not the one-way process. Rewriting the draft with something clear and understand, you will also get more clear research ideas from not only thinking, but from writing. And my favorite again, it's the author's job to make the reader's job easy. And it was my negative experience was, for example, the reviewers commented on my papers that some of the material was not very clear, and the results I described and discussed, so I did not render the science clear. To me, it was self-evident. And my advisor at Carnegie Mellon University, Professor Sheliana, she kept repeating to me the very same phrase: you are the best professional in the scientific area you are performing research in. You're the top person, and all other persons, like the grant experts, the reviewers of your paper, they are not the very professionals in your research area, in your research paper, sorry. And if you think that it's all clear, it will not be clear to your audience. So it's your job to make the reader job easy. Tell your story. Tell your story with a paper, and it's the great recommendation that you can write a paper which will be interesting to a reviewer, because if the reviewer doesn't like the very beginning, like the abstract and the introduction, he or she will not read it to the very end. And finally, some technical hints. So download paper templates from the journal website. They usually offer templates. It will save your time for polishing your paper. And also make a figure templates. The size, the resolution, the text size, the curve colors are very important before you proceed to figures. Once you have a template in, like I use Adobe Illustrator, for example, you can use also other software. So it's very important to make a template, or you will waste a lot of time to adapt your figures to the requirement of a journal. Find a template for a reference management software, because, for example, a Lab on a Chip journal or journals of American Chemical Society, they offer such templates, so you can find them, usually for Mendeley or EndNote. If you translate a paper from a different language, so please be aware it's a totally new document. And again, it's my experience. I sometimes I'm asked to translate papers into English, and the authors they usually think that translation is a mechanical process that turns the language, well, Russian language in my case, into English. In English, it's a totally different document. And for example, when reviewers analyze the document, they can write that the language is not very clear because originally in Russian, the paper looks good, but according to the writing hints, like writing recommendations for that journal, the science is not very clear. It's not about the language quality, it's about the paper structure quality. And my recommendation to all the PhD students that you should focus on starting to write the paper in the language you intend to publish it. You intend to publish it in English, please start writing in English, because again, if you write it originally, in my case in Russian, you'll spend a lot of time to adapt it. Well, thank you for your attention. Now I took a bit more of your time than I expected. Thank you for your patience. And for those of you who maybe was bored during the presentation and may remember something like spectacular, my students, they usually play some interesting pictures after the presentation. Here I placed a picture of a moving kitten. Maybe if you do not remember my research methodology presentation, you will remember it as a cat presentation. So thank you for your attention. Thank you very much.
Thank you very much. Thank you.
And so now we are finished. Thank you very much for your attention, for your participation. Now we have time for, well, we can ask each other question, we can discuss. Well, please feel free to share with us your opinion, or maybe you have also some experience and good practices. And this seminar is being recorded. It will be very important for PhD students who will then watch this record. Thank you very much. And thank you again for organizers and Inga. I hope you are here. And again, I encourage you to share with us maybe your opinion on some research practices, on research methodology. And I see comments. Could you share your opinion? Which are the main mistakes for the beginners in the PhD? Well, it's a great question. I'm starting supervising now the students, and I served internet, whereas like blogs of professors who supervise students and also of PhD students who are supervised, both positive and negative experience. And about the typical mistakes. So what I noticed and what took my attention. So again, the hypothesis is the most difficult part of the research process. And if students, they do not start with setting a hypothesis from the beginning of their research, well, sometimes and very often they develop their hypothesis before they actually start composing a PhD dissertation. It's not a common practice, but it happens, and not so it's not a rare fact. I think that's all about the research advisor to avoid the situation. Also, the contact with the PhD advisor. I remember a blog of a PhD student from one of universities of Great Britain, of top universities, I don't remember exactly, but she was not very happy with her research advisor, and the research advisor in turn was not very happy with her. They lost contact because at the beginning they didn't identify well the research plan and research activities they need to perform. And although she published a paper with them and performed some experiments, after a year she started her PhD, she has to quit. What can you advise to bachelors? I'm a sophomore student, started writing papers from first year. So again, thank you for your interest. because the modest consortium is primarily focused on PhD students, but we feel that our like outcomes of our project are also relevant to masters and bachelor students. For like skills in writing papers, I guess they're universal, and if you feel confident in writing, communicating your science, well, I think that's the first good step is, I guess you have a great supervisor if you're starting writing, research advisor if you started writing for composing papers at the bachelor stage. And here my recommendation is to rely on her, his experience, because usually we start composing papers seriously at the age of PhD, at the time of PhD program, or at least masters. Thank you. And I would also like to thank the team who is developing the modest research methodology course. I'm very happy to see Professor Marek Frankovich here, who is among the most active members of our consortium, and also the key contributor to the development of the research methodology course. So Marek, thank you very much for joining us. And I'm happy to see that the number of participants is about 70, so almost half of the registered participants actually participated in the seminar. So thank you very much.